everybody! Welcome to our 12.2 notes on exponential functions. So exponential functions, I'm sure you guys have heard all kinds of things about it in the news. Let's discover kind of what they look like and what their graphs look like, okay? So our first one starts out with, suppose that your salary as a janitor at SCC begins with 2 cents on the first day, 4 cents on the second day, 8 cents on the third day, 16 cents on the fourth day, and so on, where it's doubling each day that you work. Create a t-table for this function, so we're just going to make a nice little XY chart, and then we're going to answer the question, would you take the deal? Because it sounds like not a lot of money, but we're going to see how exponential functions work, okay? So the first day it says that we start out with 2 cents is what you're going to make. And the second day it said 4 cents. The third day was 8 cents. Fourth day was 16 cents. Okay. And it's doubling every single day after that, so let's just keep doubling. So 16 times 2. The times 2 would be 32. If you multiply by 2 again, you're going to get 64. Multiply by 2 again, you'll get 128. So we're finally making more than $1 on day 7. See, multiply by 2 again, you get 256. Multiply by 2 again, you get 512. Multiply it again, you get 1,028, so $10.28 on day 10. I'm sure that you guys don't actually want to do this 30 times, so let's see if we can figure out a quick shortcut. So if you're doubling, what this number actually is how many times we've been doubling, so this would be just 2 times itself once, right? Just 2. That was 2 times 2. 2 times 2 times 2, which would be 2 to the third. This would be multiplying by 2 one more time, which then would be 2 to the fourth, right? 2 to the fifth, 2 to the sixth, 2 to the sixth, 7th, 2 to the 8th, 2 to the 9th, and 2 to the 10th. So, if we want to just do on day 30, the fast way to do it would be to do 2 to the 30th, which you guys can type into your calculator quickly if you'd like to. And you're going to get a really big number. So if you type it into your calculator, you're going to get 107 million. Oh, sorry, 1,741,824. So quite a large number on day 30. So just if you stick it out as a janitor for 30 days, let's see here, that's in cents, so in dollars, in case you're curious, you'd be making $10,737,418 and 24 cents. So I think it would probably be worth sticking around for a month to make that kind of money. Okay, so would you take this deal? You probably would if you enjoy making a lot of money for just doing some cleanup. Okay. So let's go ahead and graph it. So let's just graph kind of the first few, okay? Because I think graphing all the way to 30 might be a bit much. Sound good? So let's see. Let's put our day number on the x-axis, and we'll put our daily salary in cents on the y-axis, okay? So day number, let's see, I think we could definitely go up to 5. I think that's not too bad. Let's just go by 5s here. 5, 10, 15, 20, 25, 30, and 35. So we can go up to day 5, just graphing that way, okay? I'm just going to graph the first 5 days so you guys can get a feel of what it looks like. So on day 1, we were getting 2 cents. Day 2 was 4 cents. Day 3 was 8 cents. So here's 10. 8 would be a little bit less. Day 4 was 16 cents. So here's 15. 16 would be just a little above. And day 5 was 32 cents. So here's 30. So that would be 32. It looks about like that. Oops. See if I can connect the dots in a nice smooth way here. Here we go. And that's generally what an exponential curve is going to look like. Is it starts off a little slow, and it picks up, and it goes faster and faster and faster. And it just keeps going up, and it's going to keep going up at a faster and faster rate as you go. So that's what they look like, okay? So let's graph an exponential function, now using an equation. So I'm starting out with the equation f of x equals 3 to the x, okay? So in general, an exponential function looks like this. It's some base raised to the x power, okay, where your variable is in the exponents instead, okay? And so that would be an exponential function. The base is this a value, whatever that a happens to be. For example 2, our base would be 3, okay? And you'll notice that a is bigger than 1, okay, for this one. So let's try a few, okay? And so let's have x be, let's see, how about, let's do -2, -1, 0, 1, and 2, just to kind of give us some negatives, a 0, and some positives, just a nice little spread to see how things go. So if I plug this in, if I have x is -2, well, 3 to the -2nd is the same thing as 1 over 3 to the 2nd, right? And 3 squared would be 9, so that would be 1/9. If x is -1, that would be 3 to the -1st power, which would be 1 over 3 to the 1st, which is just 3. So if x is -1, f of x would be 1/3. If x is 0, we would have 3 to the 0, and hopefully you guys remember anything to the 0 power is 1. Good. Next up, I've got x is 1, so that would be 3 to the 1st, which would just be 3. And if x is 2, that would be 3 squared, and 3 times 3 is 9. Okay, so now we've got some pretty nice points. We can go ahead and plot them. So at -2, our x value is 1/9, which is really tiny. It's just above 0, right? At -1, it's 1/3, which is just under 1/2. It's barely higher than where we were before. At 0, our y value was 1. At 1, our y value was 3. And at 2, our y value was 9. Okay. So smoothing everything out, of course, on the right side you can kind of see what it's doing. It's just going to keep going up, and it's going to go up very, very quickly. On the left side, well, what's it going to do? What it's actually going to do is it's going to get closer and closer to 0 without actually touching it. So in this case, that x-axis is called an asymptote. It's a line that our graph is going to get closer and closer and closer to, but it won't ever touch it. If you think about a really big negative number, just for example, that would be 1 over 3 to our huge number, which would give us a gigantic number. So it'd be 1 over something gigantic, but you're never going to get 0, and you're definitely not going to get a negative, right? And so what's going to happen is these numbers are just going to get smaller and smaller and smaller as we get to larger negative numbers. But they'll never reach 0. They're just going to come very, very close. Okay, so that's what happens is we have an asymptote on one side, and the other side just shoots up very, very fast. Okay, let's do another one. In our next example, instead of a big a value, what happens if you have a little a value, like a half? Okay, so if you notice this time our a value, it's less than 1, between 0 and 1. Negatives kind of do silly things because you end up bouncing around. So we're just going to have positive a values today, okay? But let's see what happens when we have 1/2 to the x. Okay, so let's start out with those same x values so that we have some negatives and some positives and some nice small numbers to deal with. So if x is -2, then I would have 1/2 raised to the -2nd power. Remember, those negatives basically flip your numerator and denominator, right? So 1/2 raised to the -2nd, that's the same thing as 2 over 1 raised to the +2nd. So that would be 2 squared, which would be 4, over 1, which is 4. Okay? If x is -1, that would be 1/2 raised to the negative first power, which would be 2 over 1 raised to the first, which would just be 2. If x is 0, I would have 1/2 raised to the 0 power, and anything to the 0 power is 1. Okay? 1/2 raised to the first power, if x is 1, would just be a half. And 1/2 raised to the second power, that would be like 1 squared over 2 squared, if that helps your brain a little bit. 1 squared is 1, and 2 squared is 4, so we would get 1/4 for that one. Let's go ahead and plot it. So my first point is -2, 4. My second point is -1, 2. Then I have 0, 1, 1, 1/2, and 2, 1/4. And so what we can see is that on the left side, it's going up very quickly again, right? On the right side, it's going to approach 0. It's never going to touch 0, but it's going to get very, 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 very close to it. Okay, so we have an asymptote now on the right side, and now on the left side is where it's going up very, very quickly. Okay, so let's just talk about some generalities with these graphs, okay? If you may notice, every single one of them contains the point 0, 1, because anything to the 0 power is 1, okay? When we have a values that are bigger than 1, the graph is going to increase from left to right. It's going to get bigger. The y values increase. And then when we have an a value that's between 0 and 1, and again, we're not going to deal with negatives because you bounce around and they look kind of silly. But if you have an a value that's between 0 and 1, the graph will decrease from left to right. In both cases, the graph approaches the x-axis, but it never touches it. And the x-axis is called an asymptote. Okay? The domain for both of these, they're just kind of flipped around from each other, but the domain is all real numbers. It goes from -infinity to +infinity. The range for these ones are all the positive values, but it's not going to include 0 because we never touch 0. So the range is always from 0 to infinity, and you'll notice that we use a parenthesis at the 0 because there's an asymptote there. You never ever touch it. Okay? I'm going to pause right there and do example 4 in our next video, okay?